Now here is the first question. Using the van der Waals equation, calculate the constant A when 2 moles of a gas confined in a 4-liter flask exerts a pressure of 11 atm at a temperature of 300 Kelvin. Now the value of B was given to us to be 0.05 Kelvin per mole, while R was given to us to be 0.082 liter atm per mole per Kelvin. So the van der Waals equation of state is giving us P plus AN squared divided by V squared. Now this is multiplied by V minus NB, and that will be equal to nRT. This is a van der Waals equation of state for n moles of gas of a molecule. Now we need to find what A is. So the first step we're going to take, we need to take this to the other side. So that will be P plus AN squared divided by V squared. And that is going to be equal to nRT divided by V minus NB. Now, AN squared divided by V squared is going to be equal to nRT divided by V minus NB, and this will be minus P. So we're going to plug all the variables or the parameters into these variables and find what these are going to give. So I'm going to wipe these out and work this stuff here. So we have AN squared divided by V squared, and that is going to be N. So we know that N is a number of moles. The number of moles we got here is actually 2 moles. So that is 2, and this will be multiplied by R. Now R in this case was given to us to be a 0.082. Now multiply by T. T in this case is 300 Kelvin, so I'm going to write that there. And this is divided by V minus NB. V was given to us to be 4 liters, so that is going to be a 4 minus NB. Now N is a 2, and B is a constant, which is 0.05. And so this is what you have for this part, and that is minus P. P is a pressure which is given to us to be 11. So let us find out what is that going to give. So that gives us 1.615. So therefore we have AN squared divided by V squared, that is 1.615. Now we need to take this V squared and multiply it with this stuff. Now what is V? That is actually the volume. So we're going to see that AN squared divided by V, which is 4, but this would actually be squared, and that is 1.615 on the other side. So we got AN squared, and that is equal to 16 multiplied by 1.615. Now we need to get A. In order to do that, we need to take N squared and divide through by the stuff. So A is going to be equal to 16 multiplied by 1.615, and this will be divided by N squared. Now N is 2, so N squared should be a 4. So let us find out what that is going to give. That is 16 multiplied by 1.615, and that is divided by 4. So this will give us 6.46. 6.46 is a unit. Well, that is the value. Now we need to find the unit. What is going to be the unit of A? Now we have already said that should be ATM dm to the 6th per mole. And well, so that will be basically, we got the pressure. This is a unit for the pressure, and we also got the volume, and we also got the number of moles. So moles should be squared, so I need to write that there. That means the answer to this question is this. A is equal to this. Now the second question says, calculate the pressure exerted by 1 mole of a CO2 gas at 0 degrees Celsius if the van der Waals constant A is equal to this stuff, and we need to assume that the volume occupied by CO2 molecules is negligible. We're given the gas molar constant. So the number of moles N is equal to 1 mole. And we have the van der Waals constant A. Now before we go there, we have the temperature. Temperature is 0 degrees Celsius. And this is the same thing as 273. That is 273 Kelvin. Now next up we have A. A is the van der Waals constant, so that is equal to 3.592. That is ATM dm to the 6th per mole squared. Now we need to assume that the volume occupied by CO2 molecules is negligible. Now what does that mean? If we have such a statement, what are we going to do with it? Now if you were told that the volume occupied by the CO2 molecules is negligible, that means B is equal to 0, approximately. And we know from the ideal gas equation that P plus AN squared divided by V squared multiplied by V minus NB is equal to nRT. But if we have B to be equal to 0, this is going to change. And we're going to have something like this. So this will be nRT. This is what we're going to have. And we are required to find the pressure. Notice that we were not actually given the volume. So how can we find this? Now, if you were told that the volume occupied by the CO2 molecules, or the molecules of any gas at all, is actually negligible, then you are going to take the gas molar volume of any gas at all. Now, in this case, we have CO2 gas, and we're going to take that as a normal gas whose GMV, which is going to be gas molar volume, that is going to be 22.4 dm cube. That is because we have that the volume occupied by the CO2 molecules is negligible. So the normal volume you would have would be the GMV, the volume occupied by 1 mole of a gas. Now in this case we have just 1 mole, so that is what we're going to use for V. Now V in this case is equal to 22.4 dm cube. So we're just going to hold that at the back. And we also need to know that R is equal to 0.082 whatever. So those are the things we were actually given. Now we're going to plug all them into the equation and find out what P is going to be. In order to find P, we need to take stuff to the other side. We're basically going to make P to be the subject of the formula. Now I could well wipe these out and do that over here. So P plus AN squared divided by V squared, that is going to be equal to nRT divided by V. Now next up, we're going to say that P is equal to nRT divided by V minus AN squared divided by V squared. Now N is the number of moles, so that is just a 1. We do not really need to write it, but for the sake of clarity, I'm just going to write it. Now R is 0.082. And we have a T. And T is the temperature that was given to us to be 0 degrees Celsius. So that will clearly be 273 Kelvin. Now we may be more approximate, and that will just be a 273. But if we want to be so direct, that should be a 273.15. Now we have the volume to be 22.4. And this will be minus an squared divided by v squared. Now what is a? A in this case is 3.592, and that is multiplied by 1 squared. This will be divided by v squared. So that is 22.4 all squared. So let us find out what that is going to give. So that is 1 multiplied by 0.082 multiplied by 273.15. This will be divided by 22.4. That is minus 3.592 multiplied by 1 squared divided by 22.4 squared. So that gives us 0.99276. So P is equal to 0.99276 ATM. That will be the answer to the question. Now here is the third question. Using van der Waals equation for ideal gases, calculate the pressure exerted by 1 mole of a gas when it occupies a volume of 1.32 liters at 25 degrees Celsius. Now we are given A to be equal to 3.59 atm with every other unit that is actually attached to it. Now the second van der Waals constant is 0.04271 liter per mole, and R is equal to 0.0821 atm per Kelvin per mole. So now we know that the van der Waals equation of state is equal to an squared multiplied by V minus NB, and that is equal to nRT. But for 1 mole of a gas, you do not really need to write these anymore. So this should be written as P plus A divided by V squared. And here we're going to have V minus B, and this will be equal to RT. Now, in order to find P, we need to basically make it to the B, the subject of the formula. So P plus A divided by V squared is going to be equal to RT divided by V minus B. So we're going to have P to be equal to RT divided by V minus B. And this will be minus A divided by V squared. Now we already have all the parameters which are needed. So we are just basically going to plug them in. Now R is 0.0821 and we have T. That is the temperature. T was given as 25 degrees Celsius. Now we need to change this to Kelvin. So if you added 273 to 25, that is going to give you 298 Kelvin. So here we're going to have a 298. And this is divided by V. V is the volume. That is 1.32. Now this should be subtracted by B. B is a van der Waals constant. In this case, that is actually given as a 0.04271. Now this stuff has this subtracted from it. So we need to take that into cognizance. So this will be minus A. Now A is 3.59 divided by V squared. V in this case is a 1.32. That will be squared. So let us find what that is going to give. So here we have 0.0821 multiplied by 298 divided by 1.32, and that is minus 0.04271. So this is minus 3.59 divided by 1.32 squared. So this gives us 17.094. So that will be the answer to the question. The pressure is 17.094 atm. Now here is the fourth question. The van der Waals constant for hydrogen chloride gas are given as this and this. Now from this, we are required to find out what is going to be the critical temperature as well as the critical pressure for the gas. Now you need to know that under kinetic theory of gases, the critical temperature has a formula of 8A divided by 27 RB. And P sub C, which is actually going to be the critical pressure, that is equal to A divided by 27B squared. And V sub C is equal to 3B. So in this case, we actually need to find out what TC is. So obviously, we're going to use this formula. So that will be 8 multiplied by A. Now, A in this case is 3.17. So this is divided by 27 multiplied by R. Now, what is R? So we were not given. But we know that for the fact that we're using these formulas, or units rather, we're going to use 0.0821 for it, because this is the one which has a liter, ATM, and stuff associated with it. Now B is actually 40 milli. Now we need to change this from milliliter to a liter. Now if you have milli, 1 ml is equal to 10 raised to the power of a negative 3 liter. So in order to change this, we need to introduce a 10 raised to the power of a negative 3. So that is going to be 10 raised to the power of a negative 3. And so let us see what that is going to give. This is 8 multiplied by 3.17. That is divided by 27 multiplied by 0.0821 and multiplied by 40 multiplied by 10 raised to the power of a negative 3. So that is 286.0. So the temperature here is 286.0. And that will be in Kelvin. So critical temperature, T sub C, that is 286 Kelvin. Next up, we need to find the critical pressure. Now we can use this formula to do just that. So A is 3.17, and this will be divided by 27 multiplied by B squared. Now we know that B should be 40 multiplied by 10 raised to the power of a negative 3. This should be squared because we have B to be squared. So this is going to give us 3.17. That is divided by 27 multiplied by this stuff, which is actually squared. So this is 40 multiplied by 10 raised to the power of a negative 3. So that gives us 73.3796. So this is going to be 43. Is that 43? So that should be 73 rather. 73.38 approximately. And this obviously is going to be in ATM. So that is what we have there. So those are going to be the answers to this question. Now here is the fifth question. The critical constants of water are Tc equal to 648 Kelvin, Pc is equal to 218 atm, and V sub C, that is equal to 0.057 liter per mole. So we need to calculate the van der Waals constants from these parameters. So the first one we have is Tc. Now we know that Tc is equal to 8A divided by 27 RB. Now P sub C, that is the critical pressure, that is equal to A divided by 27B squared. And we have V sub C to be equal to 3B. Now before we go on to solve this question, what if you were given another question where you are required to relate all these critical constants to each other? How would you do it? Now the first thing we need to do, we're actually going to take A and make them to be the subject from TC and PC. Now from TC, we're going to have that 8A is equal to 27 RB multiplied by T sub C. So A is equal to 27 RB T sub C, and that is divided by 8. Now from here, we're going to have A. A will be equal to 27 B squared P sub C. Now we know that A is typically A. So that is going to make these sides to be equal to each other. So that is 27 RB T sub C divided by 8, and that is equal to 27 B squared P sub C. Now here we know that 27, they can cancel out, and B can cancel one of it away. And so what is that going to leave us? That will leave us R multiplied by T sub C divided by 8. And on these other side, we're going to have B multiplied by P sub C. Now we could actually use this to derive another relation for the constant B. We know that RT sub C is equal to B multiplied by 8 multiplied by P sub C. So B is equal to RT sub C divided by 8 P sub C. This is a very important equation that we would need later on. Maybe not in this video, but you would actually need it as you continue. Now, what is going to be the last step? We need to take this B and plug it in this last equation for V sub C. So V sub C is going to be equal to 3 multiplied by this stuff. RT sub C divided by 8 P sub C. So we know henceforth that this is actually a new form of VC. VC could be expressed in terms of T sub C as well as P sub C. Now these guys, they could also be expressed in terms of the other ones. It depends on which one you would actually need to make the subject of the formula. So having done that, let us go back and solve the question for the day. So we need to find out what is the van der Waals constant A and B. So for the first one, we're just going to start with the B. This is the simplest. So VC is equal to 3 multiplied by B. Therefore, B is going to be equal to VC divided by 3. Now, VC is 0.057. So this will be divided by 3. So let us see what that is going to give. So 0.057 divided by 3, that gives us 0.019. Now that is going to be liter per mole. Next up, we need to find what A is. Now you could well use any of the remaining ones, either this or this is going to give you the answer. So we're basically going to use this one. Now A will obviously be equal to P sub C multiplied by 27 RB squared. So here we're going to have P sub C, and that is 218, and this is multiplied by 27, and we have R. Now what is going to be the R? We know that the units which we are actually using here are ATM, liter, mole, as well as Kelvin. So those units are actually going to determine which type of R value we're going to use. So in this case, that is going to be 0.0821. and I'm just going to bracket this. And that will be multiplied by b squared. Now b is this stuff. So that will be 0.019 squared. So let us find out what that is going to give. We have a 218 multiplied by 27, and that is multiplied by 0.0821. That is multiplied by 0.019 squared. So that gives us 0.1744. So I need to rewrite it. So that is 0.1744. So what is going to be the unit? And the unit is actually so long, I need to wipe it and rewrite it. So this is 0.1744, and we're actually going to have it as ATM, and this will be dm to the third, and we have a mole squared. So that is the answer for the two constants. This will be the answer to the question. Now here is the last question for the day. The critical temperature of hydrogen gas is 33.2 degrees Celsius, and its critical pressure is 12.4 atm. So we are required to find out the values of A and B for the gas. Now this should actually go the same way as we did the previous question. So in answering this, we're just going to go the same way as the previous question. Now the critical temperature T sub C is equal to 33.2 degrees Celsius. So we need to change this stuff to Kelvin. So that is going to be 33.2 plus up 273.15. So if we added this is going to give us a 5. And here we're going to have a 3. And we're going to have a 6 here. That is going to be a 0 and a 3. So this is in Kelvin. Now we know that T sub C, that is equal to 8A divided by 27 RB. Now P sub C, that is equal to A divided by 27B squared. So those are basically what we need to find out what the answers will be. So let us find out what A is from this part. Well, we do not really even have the B. So in this case, we're also going to need a V sub C. So this is a V sub C. Now a V sub C, that is equal to 3B, right? Now we had already said that we could express all these forms in terms of each other. Now previously we found out that V sub C is equal to 3RTC divided by 8PC. So this would actually be very helpful. Finding it, that is going to help us to find what B is. So I'm just going to take these ones out for now. I'm going to take these also out. We know T sub C is equal to 306 point, that should be 53, right? Kelvin. So we're going to plug that into the equation. So this is 3 multiplied by R. R will be 0.0821. This will be multiplied by T sub C. And T sub C is basically 306.5. This is divided by 8 multiplied by P sub C. That is 12.4. So let us see what that is going to give. This is 3 multiplied by 0.0821 multiplied by 3, 06.5. This will be divided by 8 multiplied by 12.4. So that gives us 0.76. So VC in this case is 0.76. liters. Now we know that V sub C is equal to 3B. So B will be equal to 0.76 divided by 3. So divided by 3, that is going to give us 0.2536. So that is 0.2537. So approximately that is what we have. So B is equal to this stuff, and this is liter per mole. Now we need to find the last one. We need to find A. Now having got B, we could well find what A is, as easy as it is. We know that T sub C, that is equal to 8A divided by 27 RB. So we could make A the subject from here. Now that is going to be 8A, and we would have a 27 RB TC. So A is equal to 27 RB TC divided by 8. So A is equal to 27 multiplied by R, which is going to be 0.0821, multiplied by B, which is a 0.2537, multiplied by T sub C. Now T sub C, that was equal to 306.5. This is going to be divided by 8. So let us find out. That is 27 multiplied by 0.0821 multiplied by 0.2537 multiplied by 306.5. This is divided by 8. So we have 21.54606. A is equal to 21.54606. So approximately we should have 21.555, and this is going to be ATM. ATM dm raised to the power of 3 per mole squared. So this is going to be the other constant that we're looking for. So hopefully by this, you have actually understood how to find all these critical constants as well as the van der Waals constants involved in the kinetic theory of gas. Be sure to subscribe to the channel and drop the notification as well as a like for this video. Have a nice day.